Here, today we see numerical which is based on shear stresses in the beam. In previous lecture, we discussed what is shear stress, then shear stress distribution in the beam. Then here, today we start some numerical which are based on the shear stress. I will take first numerical. The average shear stress across a rectangular section is 20 megapascal. Calculate a maximum shear stress. Here, whatever data you have provided in the problem, one minute. थोड़ा वेळ इकडे होगा. Then whatever data we have to provide in the problem, here in this problem, first thing is given, that is average shear stress. It is being presented by Q average. Okay, Q average. The value will be 20 megapascal. 1 megapascal, that is equal to 1 Newton per mm square. Then 20 Newton per mm square. Q average. Okay. Then to find maximum shear stress, to find maximum shear stress, Q max. What is the formula of Q max? The formula will be Q max, that is equal to 1.5 Q average, that is equal to 1.5 into 20. Then Q max, that will be equal to 30 megapascal. 30 megapascal. This is the Q average. This is very simple way to calculate Q average. Here in this problem, very simple way to calculate maximum shear stress. Q average is provided in the problem. That value is 20 megapascal. 1 megapascal, that is equal to 1 Newton per mm square. 20 megapascal, which means that 20 Newton per mm square. Here in this problem, to find out maximum shear stress, Q max. The Q max, that is equal to 1.5 Q average. Then we put up the value of Q average. Q average is provided 20. 1.5 into 20, that will be equal to 30 megapascal. That is the value of maximum shear stress. Once we calculate Q max, then draw the shear stress distribution diagram for rectangular section. Because in this problem, the average shear stress across rectangular section is a 20 megapascal. Then to find out maximum shear stress, the section is a rectangular. This is rectangular. It is a width. It is a depth. Okay. Then the stress distribution diagram will be like this. This is a neutral layer or neutral axis. Here Q max, then Q is equal to 0. Shear stress will be 0 at top layer of the beam, and at the bottom layer of the beam Q is also 0. Then maximum shear stress will be developed at the middle of the section of the beam. The middle layer, that is said to be maximum shear stress will be induced. Then this is the stress distribution diagram for rectangular section. Then we start the next problem. That problem I will read. A timber is a circular cross section of 100 mm diameter. The maximum shear stress distribution produced the maximum shear stress produced at the section of 100 Newton per mm square. Find the average shear stress produced. Also state the shear stress induced at the face of the beam. Here, a timber beam is of circular cross section. The cross section is a circular, and the diameter is provided 100 mm. The maximum shear stress produced at the section is 100 Newton per mm square. My means the value Q max is provided 100 Newton per mm square. Diameter is provided 100 mm. Find the average shear stress produced. Now, to find out Q average, also state the shear stress induced at the face of the beam. You know that at the face of the beam, the stress will be induced zero at the top layer of the beam, and at the bottom layer of the beam that is also zero, and at the neutral layer the maximum shear stress will be generated. Then here, in this problem, the circular section is given having a diameter 100 mm. Then maximum shear stress induced in the beam is also provided 100 Newton per mm square. Then you can find out Q average for circular section. This is very simple way to calculate Q average for circular section. Then here, first of all, this is the circle. This is the diameter. Diameter T. Then here, how to calculate Q average for circular section? Means diameter is given 100 mm. Maximum shear stress will be provided 100 Newton per mm square. Then to calculate Q average, the formula for Q max or Q max, that is equal to 4 upon 3 Q average. Put Q max is given 100, 4 upon 3 Q average. Then do the cross multiplication. 100 into 3 divided by 4, that is equal to Q average. Then do the calculation. After completion of the calculation, we get the value 75 Newton per mm square Q average. This is the final value of Q average. Then one more thing is also calculated in this problem. Here, shear stress is zero at the face of the beam. Always remember that the shear stress induced. This is a stress distribution diagram. I will just draw the stress distribution diagram like this. Here Q is equal to 0. Here also Q is equal to 0. This is a neutral layer, that is Q max. Okay. For circular section, the maximum shear stress induced at the middle, that is neutral layer. Then shear stress will be zero at the top and bottom also. Means that the value shear stress is zero at the face of the beam. This is going to be Q is equal to 0. Always remember, shear stress will be zero at the face of the beam. This is a very simple way to calculate the values of Q average for circular section. Whatever data we have to provide it in the problem. In this problem, diameter is provided 100 mm. Then maximum shear stress induced in the beam. That beam is in circular cross section, having the maximum shear stress value 100 Newton per mm square. Then how to calculate Q average for circular section? The formula will be standard. This formula is standard. Q max, that is equal to 4 upon 3 Q average. Then you just put up the value Q average. Q max is provided. We just put up the value Q max 100, that is equal to 4 upon 3 Q average. Then do the simplification. for our sake of convenience, then you can easily calculate the unknown values of Q average. Then finally we get the values of Q average, that is 75 Newton per mm square. That is the value of the average shear stress induced in the beam. Then one more thing is also calculated in this problem. That is here stress will be zero at the face of the beam. Always remember that if the section is a circular cross section, and if you want to find out maximum shear stress, that maximum shear stress will be generated at the neutral axis. Axis, which means that that layer neither elongated nor shortened. Neutral axis, which means that neutral layer. Okay, there will be no effect by the external load will act on the beam. Then here at the top and at the bottom edge of the beam, the shear stress will be zero, always zero. Remember that the shear stress is zero at the face of the beam. Okay, that is Q max, Q surface, that will be zero. That is face of the beam. The shear stress will be zero. Let's start next example. Very easy to calculate Q average, Q max. Simple formula is given. Sometimes you can calculate more things. I will take example. You can better understand the concept. A circular section of 100 diameter is subjected to a shear force of 3 kilonewton. When used as a beam, determine the maximum shear stress induced and the minimum shear stress. Sketch stress distribution diagram. Here in this problem, we have to calculate maximum shear stress and minimum shear stress. The section is circular, and what is the formula for Q max for circular section? Q max, that is equal to 4 upon 3 Q average. Okay, that is the very important formula for circular section. If you want to calculate maximum shear stress of circular section, then apply this formula Q max, that is equal to 4 upon 3 into Q average. Okay. Then here in this problem, we have to calculate Q max, that is unknown, and Q minimum, that is also unknown. What is Q max? Maximum shear stress induced in the beam, and Q min means minimum shear stress induced in the beam. Here, whatever data you have provided, then we calculate that thing first of all. Then it is very easy to calculate Q average. Then suppose the value of Q average, we have to calculate the formula for Q average, that is equal to F upon A, because this is the shear stress value, and we know that shear stress, that is the ratio of the force into C in the body per unit cross sectional area. Means that force to area, that is the formula for Q average. Then first we have to calculate the unknown values for Q average. Then we can directly put that value of Q average in the equation of Q max, that is equal to 4 upon 3 Q average. That is formula applicable for only circular section. Okay. Then you can easily calculate the values of Q max. Then here one more